Hey guys, so I'm getting ready to do the oxidation of cyclohexanol to cyclohexanone using sodium hypochlorite. This will be our lab this week. Um, right now, I'll show you what I'm doing. It's so cold in here, my solutions are frozen. So I'm trying to get it to melt. This is cyclohexanol. And it has a high enough melting point that it is frozen solid. The other thing, and there's going to be some modifications to the lab, and we talk about what those things are. One of them is, if you look at the temperature in the room, it's about 13 degrees, so it's very cold in here right now. The reaction needs to be around 35 or 40 degrees. So the procedure says not to really use a hot plate for heating. You're using it for stirring. I actually have this on, and I've got the Erlenmeyer flask on top so that I can check to see what the temperature is right there, 35, to make sure I'm at least at 35 degrees during this reaction. Otherwise, it may not go fast enough. I have the experimental setup. There's my my separatory funnel that I'll be using to dispense the sodium hypochlorite and also to separate out the product at the end of the reaction. Again, an Erlenmeyer flask. I have a thick-walled pear-shaped flask for the rotovap for removing the methylene chloride at the end. I have my two beakers for storing organic and aqueous portions as I do the extractions. I have a little clean test tube and something to hold it in to do the tests at the end of the reaction to see if I have an excess of hypochlorite ion. And then this is for drying later. I'll get about 10 mils of product out of this. And then I also have all the pipettes and stuff. And so what I'll be doing next is measuring out the reagents. Because it's so cold in here, I don't trust to pour it into a graduated cylinder because I think that the materials, both glacial acetic acid and cyclohexanol, will be frozen at this temperature. And so what I'm going to do is go ahead and weigh them directly on the balance. So that's what we'll be doing next. So what I've done is I've pre-calibrated a pipette actually. So we'll go ahead and see if I can get about the right amount. You're going to need to, in your pre-lab calculations, calculate the amount you need, but this should hit it pretty right on. The pipette tip has actually been warmed up a little bit so that the solvent, the cyclohexanol, doesn't freeze in the pipette, but there's no guarantee that I'll be able to get that. That should be just about the amount I need. Now you'll notice this is not very precise. Even though this pipette is very precise, this technique is not very precise because the liquid is so viscous. These pipettes are really designed for water, and so you do lose a little in this process. Now I'm going to go ahead and weigh this now, and we'll know how much starting material we have. I need a little bit more than that, so I'm going to go ahead and take this pipette and add it directly to it. That's about what I need. And then we're going to add the glacial acetic acid. I'll close that. So that's our data right there. And I'm going to put the glacial acetic acid in here. Normally you don't do this directly on the balance with liquids. You move everything off to the side. I need about 4 mils of glacial acetic acid. That's going to be around 4 grams. Now, one of the things I noticed about the glacial acetic acid, it says, this stuff smells really bad, by the way. Normally I do this in a hood. Normally it says 2 to 4 mils. Normally glacial acetic acid will be, at these temperatures, would be solid. It turns out it's not, so it means it has some water in it. That's okay for our experiment because the sodium hypochlorite solution is only 10% sodium hypochlorite. So I'm going to go ahead and add about 2 mils. You'll see it's freezing as soon as it goes in. I don't know if you saw that. I'm going to do the full 4 mils because I know there's some water in here. It's a catalyst, so the actual amount doesn't matter that much. I'm going to go ahead and weigh this though. And we're at 14.57. And you should take that as your data point right there. So next thing we'll do is we'll go over and set this up with the sodium hypochlorite. That I will measure out using a graduated cylinder. I need about 70 to 80 milliliters, so I'll be measuring that out and showing you, and then putting it into the separatory funnel to start the reaction.
So we've got about 90 milliliters of sodium hypochlorite solution. It is the excess reagent, and one of the things you can see about it is that its color is decidedly yellow. So at the end of the experiment, we'll be able to determine just visually whether or not we have an excess of hypochlorite by observing a little yellow color. It actually shows up better on white paper. I'll actually do this at the end of the experiment as well. Now, it's an 11 to 15% solution, and it's supposed to be a 10% solution. But the problem with hypochlorite is unless you titrate it, you don't really know its concentration very well, and it breaks down in sunlight. So if it's stored on shelves and things like that, it's typically not the right concentration, or exactly the concentration specified, I should say. So we try to shoot to have a little excess. So if I'm using an 11 to 15% solution, and I'm assuming it's degraded a little bit, I should still have enough to complete this part of the experiment.
So I'm going to add 4 or 5 mils real quick. That's just to get the reaction started. That was right around 5 mils. And you can see it's already changing color a little bit. And I can feel it. It's kind of warm, but that's okay. It's around body temperature. The temperature that it's supposed to be at is just around that. Now, that's to start the reaction. You can see it fuming a little bit, so you can cool it off with a water bath, just so it doesn't go too fast. Yeah, it got kind of warm there. It's so cold in here, that's why I have to run this. Now, I can turn this off to turn the heat off. And the reaction is exothermic enough that it'll probably keep itself warm. We're supposed to have an ice bath, but that room has been locked down, so I can't go in there. So that's just going to be a water bath to cool. Now the rest of the hypochlorite will go in to the separatory funnel. Move it away so I don't accidentally pour it onto the hot plate. You can see this here. And now I'll move that over. And then I'm going to have to lower that, and I'll start it dripping, okay? The drip rate is supposed to be about 1 drop per second. It's going to take quite a while for all of this to go in. So there we go. That's about what it needs to be. I'm going to slow it down just a little bit because this is supposed to go on for about 45 minutes, I believe. So we got time, basically. I don't want it to get too hot on me. I'll be actually doing some setting up another lab in the background. So running it a little slow is okay. All right, there we go. So that's set up. It's just going to run for a while. I'll come back periodically, check that it doesn't get too hot. And we'll be back in about 30 minutes. Well, you'll be back in like 10 seconds, but about 30 minutes from now. So we've completed the first part of the reaction period. There's 10-minute waiting period still, and you can see it has a slightly yellow tinge to it. That's indicating an excess of the hypochlorite. What we'll do is we'll let that sit for about 10 minutes, and we'll run the starch test on it, and I'll explain to you a little bit about what's going on with that. So I'm getting ready to test to see if the hypochlorite ion was in excess. If you wait too long, it'll always show that it's not in excess because eventually it will decompose. So what I'm going to do is put a little bit of potassium iodide from that bottle in here, right, into this test tube, and I'll add the starch indicator. The actual amount of potassium iodide I add doesn't matter. It'll turn dark blue, and I'll explain that to you in a second. So I'll add a couple of drops of this, and then I need to mix it up. Potassium iodide dissolves pretty readily. It doesn't have to even be completely dissolved. And now what I'll do is I'll take a little sample from my reaction mixture, and if you look at it closely, I don't know if you can see this or not, there's a layer there, right? And so what I have to do is I have to puncture that layer. The upper layer is product, and the lower layer is the aqueous, and that's where the excess hypochlorite will be. I don't know how much hypochlorite will dissolve in toluene, so we'll go ahead and take a small sample, and we'll put a few drops in and see what happens. And that's the dark blue that we're seeing there. Look at that. So we know that we have excess hypochlorite. I will let it sit a little longer and check it again, but the next thing we'll do is we'll neutralize the rest of the hypochlorite ion with sodium sulfide, sodium hydrogen sulfide, or sodium bisulfite. So we're going to get to that in a second. So real quickly, what's going on? So when you take iodine and you combine it with starch, that's going to give you this blue complex. The iodine actually fits into the helix. Starch makes the helix, and the iodine will fit into that. When it does that, that's when we get that blue color. So actually what we're doing is we're reacting the hypochlorite that's in solution with potassium iodide. This is kind of a redox reaction. And what we'll get out of that is the I2. The I2 then complexes with the starch and gives us the blue color. If there's no hypochlorite present, then what ends up happening is you don't get that dark blue color. So I turned off the hood light because you can see the yellow. It was too bright and was washing out the color. It still tested positive, by the way, so I'm going to go ahead and drop this sodium bisulfite or sodium hydrogen sulfate in there. And hopefully that'll turn it to colorless. We'll give it a few minutes to go. It's a little lighter. I might have to add a little bit more, so I'll go ahead and do that. I don't need to go too crazy. This reaction is pretty quick. I don't need to go too crazy, but I don't want to underdo it either. And I'll make sure there's that upper layer that it's getting trapped on, so that might do it. So I'm going to give that a couple of minutes. I've reset the starch indicator test. It's here. And so we'll go ahead and run that in a few minutes and see what happens. You can already see a pretty dramatic change actually in the solution. It's getting colorless, but it is also a lot less hazy, and we'll talk about that as I add the salt to it, because we're going to salt this out. We'll go ahead and take a little sample off the bottom. Just double check my pipette is clean. Yeah, it's clean enough anyways. We'll go ahead and grab some out of here, throw it in here. And sure enough, it is colorless. So the sodium bisulfite did its job, got rid of the hypochlorite ion. The next step is to add sodium chloride to it, and I'll talk to you about that after I get it ready and we add it. I just wanted to show you really quick. After adding this bisulfite to it, I don't know if you can see how much clearer that solution is. This is the 5 grams of sodium chloride. I'm just going to add it straight into the top. Look at that. And I'm done with that filter paper. I'll go ahead and swirl that around a little bit. I put the paper underneath it so it would be easier to see. And we're going to let that salt dissolve. We'll give it a little bit of time to equilibrate. And then what we'll do is we'll stop it, and then we'll put it into the separatory funnel. But this is called salting out, and essentially, and we've done this before, but just to remind you, when you add the sodium chloride to it, during the course of what we've been doing, the cyclohexanone that we produce is slightly soluble in water. And by adding the sodium chloride to the water, we essentially bind up the free water. The interactions between the sodium chloride and the water are much stronger than that of the cyclohexanone, and in essence it will release the cyclohexanone from the aqueous phase, or quite a bit of it from the aqueous phase. So we'll collect that up in the separatory funnel in just a few minutes. So I'm ready to transfer over. I made sure I closed that, tightened it, put a little funnel in the top. I'm going to try to do this without spilling any. Let's see how this goes. And also, there's a lot of material in here, but I don't want to get at it yet. I'm going to actually add methylene chloride to that later. We do a methylene chloride extraction. So I'm going to go ahead and set this to the side. I'll let that settle. I'll remove that lower aqueous layer. I have a larger beaker for that. And then I will collect the top organic layer. Rethought how I was doing this. I decided I would go ahead and use a larger beaker, and also to collect the organic phase I thought I would use an Erlenmeyer flask. So I'll start this process and then I'll go off camera to finish it, but basically I'm going to run this down. I want to go to the point where you can actually see the oh, and it's collecting down there. The point where you can see the organic layer come down. It's not real distinct, but it's there. And the majority of this is just the leftovers from the bleach solution. Get a gauge on the, there we go. Now I'm going to dry this. I don't have to get it perfect, but that's pretty good. So now what I'll do is I'll move this beaker out of the way, and I'll put my Erlenmeyer flask in there, and I'm going to stop the video and lower this so I don't lose any of it. Alright, so now we're able to collect that up. We can just let that run freely into there, and I have a little cork to stopper it up with. I'll let that drip out for a little bit. Touch it off. Close it. So we're going to extract with methylene chloride, and I'm going to put this liquid back into the separatory funnel. You'll see I set it up. But before I do that, I'm actually put the methylene chloride in the reaction vessel because I know there's quite a bit of product there. Again, clean pipette. Methylene chloride said it's going to drip a lot, and one of the things that you do is if you have a clean pipette, you can pump it once, and that should take care of some of the problems that the vapor pressure the methylene chloride creates. So now I went ahead and put the methylene chloride into the Erlenmeyer flask. I'm going to swirl that around and try to get, I don't know if you can see all the droplets that are on. That's all product, I think. So I'm going to try to get all that off. You notice how the salt and the water kind of glob up at the bottom like you would if you're trying to dry a solvent. And so I'm going to let that sit there, and I'm going to transfer this over. Hang on. it's sealing too well. You got to tilt it a little bit. See the product sitting there in the background. And on the top of this liquid, you could see when I did it, there was a lot of oil at the top, and that oil is the cyclohexanol. There, I got all that transferred back. And then I'm going to rinse this around and pour this out along the edges so I catch it all. If I get a little bit of salt in there, I don't really care because I'm not going to transfer that over. Or I'll try not to transfer it over. If I do, it comes out of the bottom fairly easily. Okay, so there's that. I'm going to go ahead and rinse this real good then, the methylene chloride. Remember, the density of methylene chloride is very high. So you can see it go straight to the bottom in the video, right? So what I'll be doing next is shaking that gently and trying to extract more product, and then we'll collect the lower layer in this case. The lower layer will contain our product. All right, so I thought I would just go ahead and record this as well. I think you'll be able to see this. I won't know for sure until I look at the video, but again, with methylene chloride, things like that, you need to let the pressure out. That pressure right now is just because methylene chloride has a fairly high vapor pressure, and the liquid is warm. It's not the hot plate that everything was sitting on. I turned it back on earlier to about 30 degrees, so it's not hot, but that's enough to give the methylene chloride a significant vapor pressure. You don't want to over agitate because it'll emulsify, and then you'll have to wait a long time for it to separate. I don't know if you can see that, but I'll go ahead and pick this up and separate it into a nice layer. And I'll be going through that same process again with another portion of methylene chloride. I'll put it into the flask, and then into the beaker, into the beaker, and then transfer it over. And the second time I'll actually use a pipette to try to wash things down so that we collect all of our product. I also wanted to point out I do have to collect the lower layer this time. So this is the little organic flask. I'll go ahead and collect that lower layer. There's a layer, my bad, look at that. Take that out and then open this up. And we'll drip that lower layer out. Again, I don't need to collect every single bit on this extraction. This is the first of two, so I can get rather than contaminate my product with more water, I'd much rather keep my product dry and then collect as much of it as I can on the next extraction. So there's my product. I got a little stopper for it. I'll just set it off to the side here, so you can see I got a little stopper on that to keep any of the stuff from evaporating that I don't want to evaporate. Now I can do the methylene chloride, the second portion. So that's going to be, again, using the same pipette, just around 10 mils. Place that in there. Close up my methylene chloride. Sorry, I talk to myself a lot when I do things like this. And then I'm going to use a pipette. This is the one I used for the starch test earlier, so I'll have to get a clean one. Hang on. And there's methylene chloride in there, so I'm going to go ahead and just rinse the sides down. That'll capture any of the product that might have made it away. And this is my second transfer, right? So there shouldn't be that much product in there. And I don't care about the salt getting into this beaker. I want to get all that liquid out. I'm going to do the same thing with this beaker because I can see that there's droplets. If it had been methylene chloride, it would have evaporated by now. And so, there we go. I think that got it all. And now I'm just going to add this methylene chloride here. And honestly, when you do stuff like this, doing 3 extractions, for example, it's not a big deal to do 3. We're going to evaporate all this solvent off. So the goal really is to capture as much product as you can. But I'm pretty happy with the 2 extractions. I'm not going to go past that. And so I'll go ahead and shake this and then separate it out. Again, you can see the layers that are there, right? Again, venting. I could probably go a little more vigorous in this, but you can see that when I do it, it does separate out. My experience with this kind of thing is if I shake it like this for too long, it may take 10 minutes for it to separate out. I don't know if I need to be quite that like. We'll see what happens. You can let that sit. I'll show you something here. And this is what I'm going to try to avoid. There's a little bit of water in the bottom of the separatory funnel, and what I'll do there is I'll just go ahead and take a pipette and I'll pull that out so it doesn't come out in the lower organic layer. I've already got water in my product over there, the cloudiness of it, that's water. I don't want to get more in there because the more that I do, the more sodium sulfate I'll need to dry. But we'll go ahead and do that part next. Just to really quickly show you how that worked out, you can see for the most part I got it out of the way. I just actually took some methylene chloride and blew it down in there, and it kind of separated it out. So now what I'll do is I'll take that lower layer, collect it in my organic. Everything else is waste at this point. So I'm going to go ahead and capture that lower layer and we'll re-extract it. I'm going to have a second flask for product, and we'll transfer the top layer, which is now the extracted organic layer. Or I mean the top layer, which is the aqueous layer, we'll throw that away. We're going to extract this organic layer one more time. So I'll go ahead and put it in the dirty one first, and the second one I'll have a slightly cleaner one that I'll put it in, and then we'll go from there. Oh, actually, I want to get a little bit more of that out. There we go. So that's my organic layer. Let me set that aside. This is my waste bicarbonate layer, but to be quite honest with you, you don't really know that it's waste yet. So I'm going to go ahead and what I normally advise people do is just store that somewhere else, and then like if you screw up later, right, you can always go back to it, but I'm actually pretty certain that is my bicarbonate layer. Now I can transfer this back in. That's my little stopper. Stopcock's closed. Pour my organic layer back in. Another shot of bicarbonate and extract, and then come back when we do the drying. We're almost done here. All right, so we're going to collect this lower organic layer. This is a clean flask that we're going to collect our sample in. Everything else has sort of been put away or taken care of, so I don't mix anything up here. And then we'll look at the upper layer to make sure that it's our aqueous layer as well. Oop, I did it again. You like that? These things happen to everybody. All right, there we go. Again, I'm going to try to collect most of this now because I will dry off any of the aqueous layer that might make it through. You can see droplets of materials like running down the sides inside the glass. And methylene chloride's more dense than water, so we would expect it to be the upper layer. It's actually very different in terms of its viscosity too, so when you run it out, you can actually see the difference as it comes out of the bottom of that stopcock. So that is the product in a lot of methylene chloride, and we'll rotovap that away. So next thing to do is add the drying agent, which is the sodium sulfate. So I'll go get that and we can do that part. All right, so I'm gonna add the sodium sulfate. I moved the camera so you could see it a little bit better, how cloudy that is. And then I'm gonna add the sodium sulfate to it. Remember, how much you add is kind of a subjective thing, really. I'm gonna add a scoop like that for now. I'm gonna swirl it around. Don't want to go too crazy, but the swirling, methylene chloride is not as viscous as water, and it's certainly is good at getting out of glassware. This should clear up. I can see, you can't see it, but I can see as I swirl it, it's kind of clumpy at the bottom. I may have enough. I don't really care if I add too much sodium sulfate, because what I'll do at the end is I'll go ahead and add some methylene chloride to the sodium sulfate after I transfer it to the pear-shaped flask for evaporation. So I should be able to get all of the product out of the flask. Let me do this with my right hand. I'm doing everything left-handed. So we're gonna let that go over time, and what I'm gonna do is start a time lapse on this thing. I'm gonna add one more. I'll do a time lapse and we can see what's here. So I don't know if you can see it, it's still kind of cloudy. And normally what I would do is run a column on it and try to pull some of that out. I think what it is there may have been some powder in one of the drying agent or the sodium chloride, and that's just floating around in there. So hopefully after I evaporate the solvent off, maybe that'll precipitate out and the product will be clear. So the next thing to do is to transfer this guy over to a round bottom flask, actually my pear-shaped flask. It has to be a thick-walled container because I'm doing it on a rotovap, and then I don't want to accidentally collapse the container with the vacuum. So I'll go ahead and do that transfer, and then we'll go over the rotovap and we'll set that up. Need to get the mass of our empty flask. It's decidedly cloudy. I'm not exactly sure what to make of it, but I think it's just maybe the residual powder. I'm going to go ahead and run it on the rotovap, and the product's still cloudy. Maybe we'll have to do something like that. All right, so I'm going to take this over to the rotovap, hook it up, and get going. I'll have to put some hot water in the bath too. It's pretty cold, and I'm pretty sure it won't all evaporate. You can see it's boiling, so it's probably working okay. Got a good vacuum going. I turned it down just a little bit, so that's why it stopped. Sort of the standard, I feel it if it's getting cold. I know the methylene chloride, the solvent in there is evaporating. The product, the toluene's boiling point is much higher than that of methylene chloride, so we don't have to worry about boiling off the toluene, if we're careful at least. And so now I'm going to add a little hot water to that, and we'll let it go maybe 10 minutes or so. So now we're ready to get the mass of our product, and you can use that to calculate this mass to calculate the mass of product.